Okay, so the heading is quite a long heading in the textbook. Let's think, can I make it a bit shorter? Let's say different time periods. Okay, so I did mention this yesterday, that so far we've been working with just an annual interest rate. So it's 12% per annum, all right? So if they are giving you an interest rate of, let's use that as a formula, 12% per annum. And then sometimes they will say, not always, but sometimes they say compounded annually. Then how will we write that interest rate? If we're saying 12% per annum, you can ignore the compounded annually for now because it's almost it's like a repetition. If they say per annum and then compounded annually, it means the same thing. 12%, we would write that as 12 over 100. And now I know some of you just write 12%, and that's fine, but for the purposes of this new work, let's just write it as 12 over 100. It's easier to do it this way. But then they can tell you that now actually the interest rate is 12% per annum, compounded monthly. Guys, what happens when your interest rate is just a per annum interest rate, a once a year interest rate, is you have money in the bank, and at the end of the year, they do one interest calculation, and that is the amount that they added. But if it's compounded monthly, what they do is they take that 12% and they split it up into 12 parts, right? And at the end of every month, they calculate an interest. Okay, now do we remember that with compound interest? Your interest is always calculated on the new amount that's in the bank, right? So say you invest 1,000 rand at the end of January, you get 5 rand worth of interest. Sorry, 1,000 rand at the beginning of January, you get 5 rand worth of interest during January, right? Then you're going to have 1,005 rand in that bank account at the end of January. Then at the end of February, they calculate on 1,005. Okay, they don't calculate on 1,000 interest. That's how compound interest works. So what happens here is at the end of each month, they're doing an interest calculation. But the calculation that they're doing there is your 12% divided into 12 equal parts. They're not going to calculate 12% at the end of each month. All right, that's absurd. I'll never do that. They are going to take that 12% and divide it up into equal parts. All right. Now, guys, when we're working with fractions, and we're dividing by a fraction, or we're working with fractions and we're dividing, do we remember that that means that we are tipping and timesing? So instead of dividing by 12, we are actually multiplying by 1 over 12. So this interest rate can be written as 12 times 1 is 12, and 100 times 12 is 1,200. 1,200 is what. Now, but you're not going to have to do this calculation every time. Okay, let's see an example. If it says 12% compounded monthly, you're going to put the 12 at the top. And how many months are there in a year? 12. So you're going to put it over 1,200. Okay, so the denominator that you have is always linked to your time period. So monthly is going to turn that. Instead of 100, you're going to have 1,200. Okay, that's how it's gonna work. I know it seems very strange now, but we're gonna practice all of that with you. We still put the 12% at the top, all right, so whatever that percent was, but then at the bottom, instead of 100, you're gonna have 1200. Okay. Let's do some more examples. If you are using an interest rate of 12% per annum compounded quarterly, that's also quite a common one. How many quarters are there in a year? Oh, hey, so a quarter is actually 3 months, if you want to add that there, because sometimes they say every 3 months, right? So quarterly is 4 times a year. It's every 3 months. All right, 12 months divided into 4 quarters, 12 divided by 2 is 2. Okay, so a quarter is actually 3 months. But like if we're using that concept here at the top, we're saying that there are 4 quarters. We're going to put this percentage at the top. We're going to say 12 over, instead of 100, we're going to say 400. All right, how many quarters are there? 4. So we're going to put it over 400. And that's actually all that changes in terms of the interest. Okay, it's just the denominator that changes. So however many of those quarters there are in a year, you put that in front of the 100 instead of just 100. We're going to do a few more examples because they can give you different ones as well. They can also ask you 12% per annum compounded weekly. This is not very common, but sometimes it comes up in a question, obviously just to test whether you know what's going on. All right, so 12% per annum compounded weekly. So you're going to put the 12 at the top. And how many weeks are there in here? 52. So you're going to put it over 5,200. So you can add it if you want to. There are 52 weeks in a year. So just again to remind you of what that actually means, that means that at the end of every week, they are calculating a portion of that 12%. And the portion that they're calculating is 12% divided by 52, which is what we actually have here. Okay. Another one that is also actually quite common is where they talk about semi-annually or biannually. So 12% per annum compounded semi-annually or biannually. And that basically means twice a year. Okay, so every 6 months, essentially. So we can add that there. 2 times a year. Every 6 months. So again, we're going to write that as 12 over, now because it's 2 times a year, twice a year, it's going to be over 200. All right, we're doing an example. We're doing questions like this. The formulas stay the same, all right, and nothing else changes really, it's just the interest rate and also just the end value that's going to change. So you'll see now when we do this example. Okay, so guys, this question is saying that the interest rate is 8.5%, so we're going to put 8.5 at the top. But then they're saying compounded monthly. Okay, the fact that they're saying compounded, obviously that means we're going to use the compound interest formula, okay? And they say monthly, how many months are there in a year? 12. So at the bottom of the fraction, we're going to say 1200. Now, the fact that we say calculate how much more have is account at the end of 4 years. Usually we would say that n is 4. Okay? But guys, n is now actually the number of interest calculations. Okay, so if it was compounded annually, if they just calculated the interest at the end of each year, n would be 4. All right? But now, because they're making an interest calculation every month, how many months are there in 4 years? 48. So n is actually going to be 48. Okay, I'll write that now when I write the formula down. So a equals p bracket 1 plus I to the power of n. Remember, we're working with interest now, so it's the plus formula, not the minus. Minus is just for depreciation or like a decrease in population or something like that. All right, interest, so we're using the plus formula. N is now not the number of years, it is now the number of interest calculation. Please highlight that, that's very important. If you put n equals 4 there, it's going to calculate how much money is after 4 months. All right, so you have to put 4 times 12 actually. 4 years that they calculate every month. So 4 times. Okay, equals. What is the amount that he deposited? 7,000. Bracket 1 plus. The interest rate is 8.5%, so you put 8.5 over it's monthly, so 1,200. the power of n, so guys, you don't have to work out what 4 times 12 is. You can, obviously, if you want to, but you can say number of years is 4, and then there are 12 months in each year. All right, so you can just write 4 times 12 if you want to as well, or 48, that's perfect. And then you're going to type this into the calculator. So let's see how much you're going to do it. 7,000 bracket 1 plus. We have our 8.5 over 1200 to the power of 4 times 12. I am getting, yes, 9822, 8, 5. And that's basically it, guys. Right? That's all that happens when you have a different time period. Your I is going to change, the denominator of your I, your interest rate is going to change, and your N is also going to change. Okay, so I want us to go back up to the heading quickly and just make a note there on the side. The norm of I changes and your N value changes. Okay, so that is what is different when we have a different time period. Apart from that, it's exactly the same. We use the same formulas, we use the same way of calculating. They can also ask you to calculate P, to calculate I, to calculate N. Right? You would use the exact same method. Just those two things. That's it. All right, in the textbook, they actually don't have any questions that are just like straightforward. There is one. No, not even like that one. Yeah, I think I had a worksheet though. Let me just check quickly so that I can just give you like a basic question or two just to get started with this. Okay, it was on classroom. No, actually not. Okay, then I'm just going to give you the first part of this one question. So it is exercise. So you have those ones that you was working on now, but then just from exercise 2. And 2.9, if you can just do 3.1 and 3.2. So 3.1 is just you need to use the formula exactly like the example that we did now. The interest is obviously just different. And then in 3.2, they just say how much interest has she received after 6 weeks. So you need to figure out how to, you must have done questions like that before in previous grades, when you read the document. So you're going to calculate A, and then in 3.2, they ask the number of interest that you actually received. Okay, so see if you can remember how to do that. So this comes those questions from exercise 1. Okay, you still have 10 minutes. You can get going on that.